Okay, hi. Excited to start the webinar. This webinar was really by request. There are people that wanted to know a little bit about dirty data, and I kind of combined a bunch of questions together into this, talking about what might make data dirty, and then almost things that we can do to clean up the data that we already have. You'll kind of see as we step through where this is going. Now, I called it the 5-second rule because, there are some things you can do with data that you find that it doesn't have to be inherently clean. You can do some hypothesis generating, things like that. But we're gonna touch a little bit on that as we move through the recording. So, finding our data, right? The question, the data, the tools, the skills. A big part of statistics and data, starts when we're doing analytics. But, a big part of that is also, what is your data question? Is it even answerable with data? And what data do you need to answer it? What tools can we use? What skills might you need? Do you need to bring in a consultant? Maybe on your team, there's just one skill set missing. How do you evaluate what skills you have and what skills you might need to add? And I tend to use Tableau, R, Python, a little bit of SQL, Tableau Prep, which I didn't put here, which is big, but that really needs a workshop in and of itself. I think I pulled some in here that we can take a look at. And, just a little bit about me. I'm going to turn this off so you can see the screen better. What we see here, I just like people to know that, this big data's everywhere. We keep telling everybody data's everywhere, but we seem to have this wall that everyone needs to get over to be able to access it. There's a lot of arguments going on. Are you a data scientist? Are you a statistician? Do you even have the right skill set to be doing some of the things that we're doing? And I just like to share that, this was my journey. I was at Rutgers. My undergraduate was in exercise science. I got a doctorate in chiropractic. And then, a master's of science in biology where I focused on population genetics. And then there was a hard left where I worked a bit in academia. I worked in industry. I worked for agencies. I even worked in continuing medical education. And, along the way, I formed a lot of consultancies. It wasn't until I did my own work, and really had my own voice and my own analytics and my own questions that I was invited to be a member of the National Press Club. And, I decided also, with all the data work that I was doing, I wanted to kind of have a level set because it was discontinuous over all the years. There were statistics here, statistics there, advanced modeling here. Everything was kind of disparate. I taught myself a little bit of R coding, a little bit of Python, but those were mostly solution tools. I learned enough to answer the question that I had posed, but there wasn't a lot of depth there or a lot of knowing what I didn't know. So I was lucky enough to enroll at Columbia School of Engineering and in their executive education certificate program in applied data science. And, that was insurmountable in me being able to kind of pivot my work not only into the different questions that I was able to answer and reflective of my work in open source data, but, I also found myself in a position to teach a little bit of data literacy, to do a little backfill, with some groups that I'd worked with previously that I had an awareness that they're missing certain data skills. And now I do a little bit of work, kind of fleshing that out and showing people, there's different ways to do, for example, pre and post assessment in continuing medical education. We don't serve anyone by just doing multiple choice or Likert or different types of question structures that don't allow us to really evaluate what actually happens at the point of care when decisions have to be made, clinical literature has to be reviewed. It's a very complex, and we need to reflect that in how we measure behavior, how we measure learning, how we evaluate. So I've been teaching a lot of medical education, not as many as should be interested, but we do a lot of work in discrete choice experiments, learning about conjoint analysis, what trade-offs are made when you select one treatment and not another. And, there'll be forthcoming webinars. We have one scheduled, but it's filled at 100-seat capacity. So there will be parts of that will be available on video. So stay tuned. Now, here's a really important exercise that I think is very important. And I only heard it articulated outside of my brain fairly recently. But, cognitive restructuring, if you think about it, if you're looking at a complex situation, suppose you're looking at, the choice of investigational products in a certain disease state, can you have attention? Can you believe one thing and then the opposite of that thing? And the problem here is that a thought is harmless until we believe it. It's not our thoughts, but our attachment to our thoughts that cause suffering. And what this means is, you can have a thought. An example that I like to use is around vaccines. And that's been all in the media. Vaccines, we're told they're safe, and by and large they are safe, but sometimes they're not. So you can hold the tension that we need to vaccinate. At the same time, we hold the safety question, like, gosh, not a lot of harm's being done, but when they are, do we know how to address them? Is it true? Can you absolutely know that it's as safe as they say? We don't know. How do you react when you think that thought? Do you feel like you're going to be labeled as an anti-vaxxer? These sorts of things are, especially if you work in communicating the data and the insights and information generated, how do you approach that? And that's kind of like how I think we're supposed to do it, especially if we work in journalism or we, communicate the data. And, it's not a bad thing to hold tension. And I like the way Graham Duncan describes it. If you have a room with different tensions, right, there's going to be a lot of heterogeneity about, the way we look at our data, the data we choose to inform us, how we find the data, how we bring it to the discussion. Those are all different tensions, say, even around a table or in a room. And if you think about tension, it's like playing a note, right? You can harmonize and they can play in a different context. And it's quite all right. Now, a big problem that comes with storytelling, and I know we're all about telling stories with data, when you tell a story, like when my personality comes across in the story that I'm telling, what comes with it are my biases as well. And while we can't eliminate them, we can certainly acknowledge them and be a little more transparent. Especially around some of the more popular ones, like the Texas sharpshooter. When we go into these huge data sets and we feel like, hey, look, I see a pattern here. This must mean that this is happening and this insight is true. Well, really, we're just cherry picking the data clusters, right, to support whatever argument we're trying to put forward. So we have to be very careful about that and appeal to authority. Whether we're talking about a pharmaceutical company, a CEO, somebody we collaborate with, maybe this person is going to sway us in what we think or not think because of what we attribute to them. So these are all different ones that, take your time to kind of step through them. Some of you've certainly heard before, like the slippery slope and the straw man. They're often in the news. But it's really interesting to kind of recognize yourself in some of these, like manipulating an emotional response in place of a valid or compelling argument, appeal to emotion. Kind of reminds me about the Alzheimer's clinical trial being stopped. We see the pictures of our parents and our grandparents getting elderly and forgetting, and that's the big marketing campaign that happens around more money being invested in Alzheimer's research. And a lot of it has been going into the same buckets. And now, that appeal to emotion can be extremely powerful. And by now, especially if you've been to any of my webinars, we recognize these two guys. They both have won the Nobel Prize, behavioral economics, although, we have a psychologist, but there's not really a Nobel Prize in psychology. But if you can look and read these books and just get an awareness of how we all have these mental glitches and heuristics, rules of thumb that we rely on, and that could get us into trouble if we think we're being objective, when really we're just kind of repeating what we already believe and what we already believe to be known and factual. This is a beautiful chart, just looking at how we notice flaws in others more easily than flaws in ourselves. Like, no kidding. And, back to the storytelling, if you go back to the too much information side of the circle, we find stories and patterns, even in sparse data, right? We fill it in and we think we know what the data is trying to tell us. And there's a lot, just looking at the fallacies around here, it's amazing. But this is just something to look at to understand the complexity of when you introduce a human into the insights and into the analytics, you bring a lot more with it than you might imagine. And, Mona Chalabi is just a wonderful, follow her on Instagram. She's great because you can actually see how she generates these, where she starts when she's looking to build these graphical representations of data. And what's so wonderful about it is her quote here, drawn by hand to remind people that data isn't objective, nor is it perfectly accurate. And, that's in any graphic that you look at, right? You can bring data to the conversation, but why this data and not that data? Why do you decide that these metrics give you the full representation, but maybe you're not bringing all the data that you could to the table or to the conversation? And that kind of goes back to the Byron Katie. Is there data out there that if you pulled it into your analytics, it might refute what position you're trying to take? Well, that data still needs to be part of the conversation. So, we need to begin with the end in mind. A lot of times in collaborative relationships, people get excited when somebody like myself, who works a lot with Tableau and data visualization, as part of the conversation, they think we're going to start doing Sankey charts and beautiful renderings. And, that's not where, if you think about it, that's like very little. Those of you out there who are work in data visualization, that's like the best day of our week, right? Everything else upstream from that is a lot more laborious and, time sensitive. So first of all, we need to understand what question we're trying to answer, because it's not just a matter of being Texas sharpshooters, right? We need to have a question because we also need to understand if the question, the way it exists, can even be answered, A, and can it be answered with the data we have on hand? It might not. We may need to frame the question a little differently to be able to translate it into something answerable by data. And then it's also good to sketch out a feasible analysis. Are we looking at time series? So we're going to look at something a little more linear. Are we looking at, what kind of variables are we going to bring in? Sometimes sketching out, especially if you're working with someone else, managing their expectations. Once you start sketching things out and they become visible, you can kind of make sure you're on the same page. Because let's face it, we all don't have the same verbal acuity around data. And I think it's really important to make sure the vocabulary is clear and that we're all on the same page. Now, Not So Standard Deviations is a great podcast that I love to listen to on long runs because I come back a lot smarter than when I left. And Hillary Parker is a gas. She's just really funny, and she just brings things to light that are very approachable. She co-hosts this with Roger Peng. Roger Peng is over at the Johns Hopkins, and I've always followed him. That was the first data heavy course I took. It was a Coursera course back in the early days, and it was tough. I mean, it was hard, but I made it out the other side, all the better for it, but it was good. So what Hillary was talking about with this common visualization is around Hadley Wickham, who is very big in the R community. You've probably heard of him if you've even dabbled slightly in R. But, you know, he talks about tidy data, and we bring data in. So that's around the data selection, how we find the data, we bring it in. Tidy is how we make it like analyzable, right? We clean it up, and then we transform, we model it, we transform it, we visualize it in a, you know, it keeps going around and around as we, you know, get more data in to make sure the question's being answered. So we test the model, you know, how is the model fitting? Do we need more data? Do we need, you know, all of that happens sort of within that box. That's like the exploration phase. And then we communicate the data, the findings. But like I alluded to earlier, I mean, look at the tidy part of this, right? You get the data in, it's probably really tiny, the part where we actually find the data, and the tidy bit is huge. And that's kind of a little bit about what we're talking about today, is the cleanliness of the data. But I like to start the discussion about the cleanliness of the data, even upstream from the tidy part, because I think it's extremely relevant. Is the data you're bringing in the right data to answer the question? I have a hard time separating that from like cleanliness, because you can have the cleanest data set that you want, but if it's not up to the task of answering the question, what's the point? And, you know, again, look at this also too. Sometimes the data collection is the biggest part, finding that right data. My area of expertise tends to be around open source data, for the main reason that I feel like there are a lot of people out there with data questions that don't have the budget or the access to these proprietary data. I get some proprietary data through my role in journalism, just because it serves people well to have data that people can see publicly discussed with like a citation, and then it drives more people to the data. But for the most part, most of the data outside of a few registries that I have around phase 3 oncology data and things like that, most of the data that I use comes out in the public space. And I feel like people aren't aware of how many of their data questions can be answered using open source data. And here are some of the tidy tools that you work with data frames, right? Data frames are sort of like these tables that you see here. Each variable is a column, each observation is a row, and each type of observational unit is a table. And, you know, it doesn't show up that way. You kind of have to make it this way. And there's library packages in R that can help do this for you. And then there's pandas in Python that can do that for you as well. And, you know, a reason why it's super important to be able to look at your data and not just look at the frequency tables or look at the summary statistics, because there's something called Anscombe's quartet. And if you look here, the Roman numeral 1, 2, 3, 4, and you have these two, each column of data, and you can tell visually that these numbers are all different. But when you look at the summary statistics, you can see the mean is the same, the variance is the same, and the correlation is the same. So this kind of speaks to, you know, when we look at difference of the means, you know, that can mean something completely different, which is really important when we're hearing discussions in the news about maybe we need to remove the p-value and significance. This is some of the reasons why. And if you look at these correlations are all identical, but if we take the time to actually visualize the data on the X and Y axis, what do you notice? You notice that it looks different, right? The correlation is expressed differently. Sometimes that correlation is achieved based on outliers that kind of just pull that to a different level. And then some of these have no relationship whatsoever. I mean, look at X4. So this just shows and demonstrates how we need to visualize the data to really see what's happening, because outliers are important, missing data is important. These are all things that need to be transparently communicated of how they were handled. And I like to do my Elvis toast example. I think I've shared with many of you that it used to be Jesus toast, but it caused so much controversy that I was like, all right, let's get Elvis. So Elvis is here. And what this means, first of all, is, suppose your toast pops out and Elvis is on your toast. You're thinking, wow, my toaster makes Elvis toast. Well, how are you going to check that? Because you could either take the toast that you have that already has that imprint and that information on it with Elvis's likeness and put that back in and then have it pop out again. And then you could say, see, I was right. My hypothesis was that I make Elvis toast, and it was confirmed. But now you can kind of see a little bit of how this aligns with data. If you take your data set and you create your hypothesis in it, and then you go back into that same data set and you pull, do your hypothesis confirming in the same data set, it's kind of like putting your Elvis toast back in the toaster. And that's why in machine learning, we train data on one part of it and test it on another. So you just have to be aware of that. And, this story that I put next to it, sometimes what we can say about the data set is really just what we can say about the data set. We're not really able to extrapolate to larger populations because of decisions that maybe we made upstream in the data, in our data journey, which is why it's always good to have somebody with a little data savviness, as scientists, analysts, somebody in that realm with you. Because when we're storytelling with data, not only does it go back to its origin, but it also goes back to that fundamental question. And usually somebody with the data expertise is going to make sure you formulate the right question. And then, I wanted to touch back with Byron Katie as we look at this next bit of data here. This is that vaccine data I was telling you about. And look at the headlines are horrid, the deaths, the emergency. And we might often ask ourselves, well, how are we going to make inroads with a population where we're having this problem? I would argue that shaming people into it isn't the answer, that maybe we need to kind of understand where they sit. It's not all about worrying about them having Asperger's or something. There's more to it than that, and we're not really looking deep enough. So I wanted to remind everyone about the immunization schedule from birth through 6. And you see, like at birth, they're hitting them up with Hep B. And, we could ask ourselves, I'm not an anti-vaxxer, but I would ask myself, how many prostitutes are my fresh newborn son going to run into, and IV drug users, moments after birth? I don't know. Maybe this gives parents pause. I don't know. I do know that you don't get your first MMR until around 12 months of age. And a lot of these babies are being exposed by families that don't vaccinate older children. So there's a complexity of questions here that maybe we need to reach out to the community better. Because I can actually tell you, my youngest son had serum sickness, violent reactions to vaccines, and I hesitated to get him, I don't know, a second round of something. I don't recall at the time. And the pediatrician fired us. I mean, he didn't listen to me. He didn't figure out like, well, I see why she's concerned because her son had this reaction. And my next pediatrician was amazing. He drew the titers. He says, you know what, we really don't have to vaccinate your son right at this moment because he still has a lot of protection from his last shot. Let's watch him. Let's see how he does. Let's, continue this conversation. That's supportive. And, it's kind of funny. We think all this stuff is just from people, in the Pacific Northwest that are like, these parents that parent differently than other parents, but this has been going on since the 1800s, where people have had suspicions around vaccines, and you can tell by looking at these diagrams. There's like a pig coming out of this guy's nose over here. I don't know what's happening over here, but you know, it's kind of funny to see that it's not just some new age thing, that there's always been a bit of a, you know, hesitation. And now if you look here, this is the CDC Wonder site here. Let me see if I can open it up. Okay, if you hold on, let me just log in. I just want you to be able to see this, how easy it is just to go in. And this is just an example of data exploration. There's nothing I expect you to, but you know, it's kind of interesting to be able to know that there's databases like this that you can literally go into if you want to write a story, if you're a journalist. I know I have a lot of journalists that follow me. Suppose you want to talk about measles and you want to find out, well, really, why are people not getting their children vaccinated? You can go in here and look under symptoms, vaccine type, doses, lots, days in the hospital, event categories, was there death, was it serious, who administered it. This would be your key variable here, because this is a unique identifier of patients in here. And then you can do group bys and get a few things here, group results by different measures. You can add in lab data, adverse event description. You can title it, and then when it runs, it'll come out with a title. You can look at specific symptoms if you're interested. You can go by specific vaccines, manufacturers. You can go by state. You can go by ages. You can look at death, life-threatening, permanent disability, hospitalized, whatever you want to know. How long was the interval of onset? How many days were they in the hospital? I mean, you can see all of this depth. You can pick date ranges. This is powerful stuff that's like freely available for any of us to go in and take a look at. Let me open this back. There we go. So now, if we go, you know, for the sake of time, I'm not going to jump into all these live, because this is a quick discussion we're having. But this right here is Tableau Prep. So what I did, you can kind of see what field names I selected right here. What I did is I did an export of all of that data into an Excel or a CSV file. And these were the column names I picked. So you can see right here, the adverse event description, all of that is here. And this needs to be clean, right? I need to do a little tidying on this before I really can dig in and start analyzing. So what you first notice here, all you do is you add a step, and automatically Tableau Prep does a preliminary cleanup for you. And the first thing you usually notice is nulls, because we have to figure out how are we going to handle nulls in data sets. Are they zeros? Are they missing data? Are they not a number and they're another value? We can't just like summarily say, well, just get rid of them, because you don't know what influence that may have on the data sets. But what I found out here when I went in is I checked the null, and what it was these IDs where there's no ID. So if there's no ID and no way that I can connect the different columns together, I felt comfortable removing them. And if you go back into the data dictionary that comes with this, you find out that the IDs had changed over time. They didn't always look like this. So I decided that I was comfortable eliminating the rows that were null. And so right here, you can see that they're all going away. And now they're gone, and the data, you know, there's no more nulls left. There's some crazy things going on here, because a lot of this is hand-entered things. So you have to do a little sentiment analysis or something like that to really understand. But you can see when you pick your columns here, you get a little snapshot of what the data looks like below. And that's very, very powerful stuff. A lot of times I do pharmaceutical company level data, and some of the pharmaceutical companies are, you know, if they're global, they have different names. Sometimes if I'm looking at analytics, I can group some of them together, and I can create groups right here in Tableau Prep and clean it up and get it ready for analysis. So, when we're looking at when we're using R, remember that every function has three basic parts. You name your function. You could call, you could call it var's ID, or, whatever you want. And then there's the body of code, and then the arguments that you set against the code. So that's all you need to know to be able to write a simple code. Like right here, here's the name. Here's the body of the function, right? It's saying function and what you call for here. And then in here is going to be the set of the arguments. And the reason I showed that to you here is because I brought the same data that I brought into Tableau Prep, and I showed you what it might look like if we brought it into R. And very easy. If you look here, obviously you're not going to learn how to R code in this quick little time that we have together, but I just wanted to show you the simplicity of the code. Here's the library. Here's the library right here. I read in the CSV file. So look, this is it. This boom, boom, boom. And then look what it generates. So just knowing those three, knowing what packages I need, the tidyverse, right? That's what's going to clean up the data. The read Excel, which is going to help me read in the CSV file. This is the name of my function. This is the name that I gave it here. Here's the function. And then if you come down here, all I'm saying is, oh, look here, this all comes out. It's all parsed with column specifications. What that means, it's going to tell me what type, what's in that, what's in that column. So when I look here, I can see the headings. So it shows me these are the headings, and it gives me a little sample of the data that's inside. And then it can summarize that data. And just like we saw in Tableau Prep, there's other things to look at in here. You get your character class as an integer, what is it? But more importantly, it tells us right here, we have 54 NAs, right? The way we found them in Tableau Prep is we saw them right at the top of the column, but here we also see them. So this is really quick, free. It's our cloud, our code, and down the road, I'm going to be teaching a little bit of how to pull your data in and clean it with R and how to do some analytics. But I just wanted to show you that today. And then if we look in here, I think this goes live to Tableau Public. Let me see if I can show you. Yeah. So here's our data from Tableau Public. Now, what's kind of neat is this part right here. This animates when you go live into your own dashboard, but Tableau Public doesn't animate. So, but if you look at, you can look at the rotavirus, and you can look and you can see how many deaths, less than 6 months, life-threatening, permanent disability, and you can click through all the different vaccines that were out there for this particular year. And, you can just, it's very informative, because you can say, maybe you only want to look at the young babies. Maybe you want to look at you can actually see people down here as well. Somebody died of influenza. Now, you can also go down here and find, these are the adverse event descriptions. So here's an example. This is something you could use sentiment analysis to clean up, but I just wanted to show you the breadth of the data. This is a hospital report where there's a 1-year-old fully immunized baby that all of a sudden shows up with a seizure after having his vaccine. We hear these horror stories. This is what sticks in our head. We don't really think about the thousands and thousands of other babies that have a normal outcome. We think about these. And this is why maybe parents delay, because no one talks about this. So let me go back. Okay. So now to return to bringing in problems that are solvable with data. Data's everywhere. I mean, look at this, right? I'm not saying all this stuff is open source, but this just lets you know how we are awash in data. And there's just so much that, we need to consider. I use a lot of these things to find out what type of data might benefit me when I'm trying to look at bringing data to the table to answer a question. Maybe I want to know about risk-bearing entities. Where do I find this data? Where can I find value-based care? And I start doing a little research about what that data looks like. What are the column headings? Can I find data similar to that that's open sourced? Can I find real-world evidence? Where's the trial data? Where's the health economics data? How about pharmacovigilance? Pharmacovigilance data is very easy if you use things like Medra, which is like, I think it's like $200 for the entire year. And you can go into the FAERS database where they have adverse event reporting, and you can look for a drug post-market and compare different drugs. I have there's another webinar that I did that takes you actually into those databases, and you can reach out if you'd like to find it. I think I priced it at like $50 because it's a 2-hour workshop, and we're actually, manipulating data. It's out there. You can find it. So what I'm saying is, like, so when you look at things like this, there's a lot of places you can go to try to find out what might be available to you, where you can look at some of this data yourself. Because, right, these are all originators of data. There's government entities that you can reach out to. FDA has all of this stuff. You can find free data in anything in this government entity box. And, now with that impression of that large volume of the data out there, out in the system, you can think about, now should we talk about data quality? I always like this picture because this reminds me of this is like a climate change or like a pollution kind of thing. Like, now is a good time to talk about air quality. I wouldn't wait until your room's filling up with smoke to want to have a conversation about it. And the same thing with data. I see a lot of data that's been collected, and a lot of people want to go upstream from now and say, wow, we've been doing this for 25 years. We have so much data collected. Well, it's unstructured, probably. And if it's not unstructured, were you asking the right questions to generate the right data? Because as I've alluded to previously, sometimes we don't have the right data to answer the data questions we have now. And if we're not collecting our data in a meaningful way where we can calculate probabilities or think about risk benefit, we really are out of the game for how people are using data today to make informed decisions. And that's kind of the difference between explanatory and exploratory analytics. Explanatory is what many of us have been doing, right? We get data, we need to look at it, summarize a quarterly report, what have you. Exploratory is more where we have a mission. We're going into this data set and we're trying to have a look-see and see if there's anything of value. And those two things require very different statistical rigor to be able to say anything meaningful that's not just a correlate of something. The old saying, correlation is not causation. We don't want to introduce that into our data queries. And, this I love because it's from the Royal Statistical Society that used to say back in the 1800s, this little banner across the wheat was to be threshed out by others. We're going to give you the numbers and the data, and here, take it and, do what you can, not to be political, but kind of Mueller reporting, right? Here's a bunch of information, have at it, And what we're clamoring for is, what does this say? And most of us might agree that maybe 40 words that summarize a 400-page document aren't really going to be complete enough for us to really know. But I think it's funny that how very quickly the Royal Statistical Society took off that to be threshed out by others and took the task on of, what, we're going to help you here. We're going to give you some information around the data. So how data scientists think. This is Roger Peng. I was telling you about him earlier. This is a really good paper that he wrote, a blog, maybe it's a blog, but I like the way he presented a mini case study and then gave his reasons for how he stepped through it. And it's not technical at all. He's talking about like transportation time from work or something like that. So it's not something really erudite. And I know a lot of people like backup resources. I like this book a lot. It can be kind of technical at times, but it's a worthwhile investment because it talks about visualization, analysis, and design in a really meaningful way that kind of integrates everything together. And I get nothing if you buy this book. I'm just sharing it as a resource, something that I pull off my shelf all the time. And this is just a quick example, the way they talk about data types and attributes. I'm always talking about attributes when people are trying to figure out how to make, how to write a proposal. They're trying to examine a question in rheumatoid arthritis or in immunology or something. What kind of data are you looking for? What type of data is it? Is this multidimensional? Are we talking about arrays? You have to kind of know what type of data you're looking at so you know how to structure your analysis. And this visual vocabulary chart by Financial Times is brilliant. I think you can either buy it or download it and get it bigger where you can kind of read it. I have a bigger one that I can actually read, but it gives you some kind of insight into what data types you need. Like, are you looking at a deviation? Do you want to correlate? You want to know how things are related or correlated? Are you ranking things? Are you looking to see what part to a whole? How about spatial? How about temporal data, time series that change over time? These are all really important questions to ask yourself around your data question. And back to this Tidy Tools data frame, because it's important to have it and to remember it. And then when we go into data curation, we know that the Google data set search, a lot of people don't know this is out here, so I am going to pop into this real fast because we're starting to run out of time. But right in here, that what you saw there up here, I put in claims data. You would think that claims data is under lock and key and no one can have it unless you're IMS data or whatever they're called now. But you can actually start looking at Medicare Part D claims data right from your computer. And this is what the page shows you. And there's other types too. There's the CMS, Medicare provider utilization and payment data. I always pick the latest data that I can get my hands on to play around with. But this is all data that you can download and bring it into Tableau Prep. You can bring it into your Excel spreadsheet. You can write a little bit of R code and figure it out. And this is another, I call this my cheat sheet. It's not really a cheat sheet, but if you look at it, if you want to look at risk factors for disease, you got to kind of know where the data might be stored and how you can find it. You can look up risk factors for almost anything. You can look at comorbidity patterns. This is a good way to start thinking about search terms and how you can find information that you want to use, especially in the real world environment. This is a little bit of the ggplot, these little cheat sheets that you can get if you use R. It tells you what's out there, how you can plot data. It's really the idea that you can build a graph from the same components. All you need is a data set, some sort of a coordinate system, some kind of independent variable, and then whatever visual mark that's going to represent your data. This is another one about dplyr where we're going back to look at those, the data tables. And these are all freely available on our cloud, our studio. You can find them and you can figure out, well, what can I do? How do I combine tables? How do I combine data sets? This is Makeover Monday, which I recommend anyone go in and do. You just Google Makeover Monday. These data sets that you see in here are completely clean. They're all cleaned up for you, so you don't even have to think about that. You can just focus on, doing your analytics. And the one that I used in here is this one down here, Digital Economy and Society Index. I'm not going to pop into that because we're running out of time, but that's the one that we used. And you'll see it right here. And this is what they give you. This is what they was shown, and they tell you, all right, can you do better? What's missing? What do you like? What would you like to see? Those sorts of questions. And you take the data set and now you can move it forward. And so what I did here is I looked at the spreadsheet just to kind of like to give a good look and see what's going on in the data. We have the year data here. So you kind of know, is is there any hierarchical data here? How many years might be here? So we can know this when we're going in to analyze the data. It's always nice to have a weighted score so it's not distorted. And we have country codes, so that if you're using Tableau, you can generate like a map. And this is what I did really quickly in R. I wrote really quick code. I just pulled it in. I just pulled it into R and did a quick plot of the data, and this is what I found. So you can kind of see the data that I used here, that I pulled in for ggplot. And you come over here. Now think about what we saw here. There's not a lot you can say like really quickly, insight-wise. But what I can say here is, I can look right here, the weighted score. These countries are doing better around human capital and connectivity. More people are connected, and human capital, more people are trained in how to do this. Where are we not doing well? Integrating this into our communities, digital public services, all with a couple quick lines of code, just written very simply right into here. And I blew this up a little bit just so if you wanted to take a deeper dive, and I'll be glad to share the slides with you. If you just send me a note, I'll be happy to send it. And then, I did look at it again in Tableau. And I think this might be broken live I don't want to take time away because we only have a few minutes left. But what you can do here, just go to Tableau Public. And if you look, Datamonger Bonnie, and you can play around with this. So what you can do here is you go to the year, and if you cycle, it's not live here, I just took this picture in case the link broke. But if you hit this, these are all going to shift at the same time these shift, right? I didn't want to make it so super tiny, so I just kind of blew it up here so you could see, but you'll see all the different measures when you go to Tableau Public. And what's great about this is a trace. What you see white is letting you know that if we're looking at 2018, here's what it looked like in 2016, 2015, 2014. But our eyes don't do a really good job of discerning size of spheres. So across the top, I built this linear model so we can watch how these change up here in combination with the trace of the map, the spatial map. And that's just an example. I mean, all of these visualizations took about the same amount of time, but you can see the power of Tableau and being able to visualize this data. R data, the R programming, you can look really quick about insights. If you have a slightly more time, you can do the Tableau. And, Tableau is really my area of expertise. It's been a leader in data visualization for a very long time. You see it here in the very recent Magic Quadrant release. Here's somebody that I tend to follow a lot, Andy Kriebel. He does a lot, in a lot of these too. This is the visual vocabulary that I showed you from Financial Times. He breaks it down and talks about it here. But a lot of these you can actually download. Same thing with my work. I've just started using Tableau Public because now that I work independently, I have a lot of non-proprietary stuff that I could share. But if you look in here, you can actually download the data. You can play with it. You can maybe do something similar with this by downloading it. So, I suggest you take a little time to explore because, spreadsheets are very limiting, right? This is what I look like when you give me a spreadsheet. Spreadsheets are very limiting, but when you learn how to manipulate them and clean them up, you can do a lot of good work. Like here's another example of, Tableau Prep, where that's the same data that now we've pulled in and we're able to clean it. We're able to look at it, right? We're able to look at column headings. We could pivot data if we want to. We can do a quick query into total claims or dosage units, because you can't really always compare one drug to another drug, because sometimes in clinical trials, one drug in one cohort is at a different concentration and dosage than another. Well, how do we compare that? So these are just simple ways of different columns and different ways of looking at data based on a few tools that you can have at your disposal. And, we always have to talk about Richard Feynman, right? He says the statements of science are not what is true and what is not true, but statements of what is known with different degrees of certainty. There is really no truth. There's more like a probability. I'm 98% sure. I'm 85% sure. In this cohort, there's this certainty. And we have to remember that when we're bringing data to the conversation so we can know how different data might influence this. And this is a little rule of thumb to keep nearby that I'd like to leave everybody with is, what data do you need? You really need to have a certain amount of expertise in knowing where this open source data is. Reach out to me on Twitter. I can send you, I think there is one slide that I can send you that has a link with all of the data sources that I used in that workshop that had a small fee associated with it, but I can certainly share those data links with you if you'd like to try to go in and explore on your own. And then if you need some help, the webinar exists, for download once you register and pay. So when you're creating your visualization, you need to say, what data will I need? What type of data am I looking for? Can I find the data to answer the question that I've posed? What variables would you like to see in that ideal data set? How will you visualize this data? Are you going to look at it in a spreadsheet? Are you going to look at it, in a ggplot? What do you want to look at? Is it going to be a map? Do you want to see something, demographically? What questions will you need to ask? Do you know how to ask them in the right way that will get you accurate data that actually answers the question that you're posing? Do you know how to clean or restructure your data? And what are you comparing? Is this a comparative data? What are you trying to figure out? What do you want to know overall? And so that's about the time that we have. Now, I want you to feel free to reach out, over on Twitter or send me an email. I can get some of these slides in front of you if need be. And this will actually be available for download as well. So, reach out to me for some of the resources that you think might be of some help. And I appreciate your time, and I will talk to you soon.